Now in GCSE, you will have learned a lot about different types of graphical representations. For example, bar chart, pie charts, line graphs, pictograms, including today's lesson about box plot, and then you also learn about histogram, etc., etc. But among all of them, box plot is actually one of those being used the most frequent later on in the nowadays research. Albeit even though they might use the box plot in a vertical way, but box plot is actually one of the most common type of graphs if you do any academic research later on. Huh. Right, so today we're going to learn about the components of box plot. We're going to learn to construct a box plot from given data, and we're going to learn how to interpret the information from the box plot. I think I've said the word box plot too much. Box plot, box plot. Anyway, a box plot, also known as a box and whisker plot, um, is a graphical representation of the distribution of a data set. It displays 5 key statistical measures, okay, that can help us analyze the spread of the data. So how widespread the data is in a data set, how wide the first number to second data, etc. Right, so I have kindly color coded for you. So first of all, on the front and back, you've got the minimum and the maximum, okay? And then, so minimum, imagine is like a 0%, maximum is 100%. And then from 0% to the first, another key number, which is 25%, is the lower quartile. And then from 25% and 50%, which is the median, so it's the 50% percentile actually of the data set. And then 75% is upper quartile. So these 5 numbers, these 5 straight lines make up the box plot. And then you just have to connect the box in the middle using a lower quartile, upper quartile. We know the difference between upper quartile and lower quartile is known as the interquartile range, so IQR. So there's a hidden information, I guess. It's a sixth statistical measure, I guess. These lines are just called whisker, so it's box and whisker. But normally I just call it box plot. Here's the example. The table shows below, well, some information about dataset. Can I ask you use a pencil, and a pencil, please? Very important. 3 times, pencil. So we're going to draw a box plot to represent the data. Okay. So we know the minimum is 40. So that's the first number. Now, how long the line, okay, it doesn't really matter. So as long as they are sort of consistent. So I normally make it sort of long enough. Maybe if I say, just say from here to here. Okay. Next, the lower quartile 68. So 68 is here. And then median is 74. 74 is here. And then upper quartile is 84. 84 here. Next, the maximum is 90. So the maximum here is 90. Then what we need to do is to connect we need to draw a box between the lower quartile and upper quartile. So draw a box like this. And we just have to draw the whisker. Like this. So use a ruler, use a pencil, and that's your box plot. Okay. Part B, work out the interquartile range. So interquartile range is the upper quartile minus the lower quartile. The upper quartile is 84, the lower quartile is 68. Take it away, which is 16. That's the interquartile range. Here comes practice question 1. This time the upper quartile is missing. Have a look at the question, see if you are able to work it out. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Well, we know the interquartile range is 27. It means between the lower quartile, upper quartile, there's a difference of 27. So therefore, the upper quartile will be 87, because 87 take away 60 is 27. So once we've got the upper quartile, then we're able to draw it out. So that's a minimum. That's the lower quartile, median, upper quartile. Draw a box around it, and then a maximum, and then draw the whiskers. Here comes practice question 2. Now this time, instead of giving you all the numbers, the 5 key statistical number for you on the silver platter, they are actually scattered in a discrete format. So these numbers are discrete data. So 15 students running 100 meters in the times below. Have a go at the question, see if you're able to crack it out. when you're ready for the answer, you can press play. Here are the answers. So I've given you all the numbers in here. If you work it out, able to work it out, draw a box plot, see if you're correct. If you're correct, well done, move on. Okay, but if you don't, I'm going to go through step by step how to work out these numbers. Now, first of all, needless for me to say, minimum, maximum is the first number and the last number. Now, this is the case because these numbers are already ranked for you, ordered for you from the smallest to the biggest. If they aren't, you have to put them in order first. Next, to find a median, you can do it the same way like you did for the stem and leaf. You could cross up front and back in pairs, front and back, until you got one number or two numbers in the middle. So you see 12.3 is the median. Next, what you can do next to find out the lower quartile, you just have to work out the median of the first set of number. So the median is the middle number. So after that, you're going to use that, break it into two set of number. You can work out lower quartile. So front and back again, front and back, and that's the lower quartile. Now, what's the shortcut? The shortcut is to find a median. You can do add 1 and divide by 2. So there are 15 numbers. If you do 15 plus 1, which is 16, 16 divided by 2 is the 8th. So it's 8. So it's the 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. That's the 8th number. Lower quartile, you can work do the same way. 15 plus 1, you have to add 1 because that's how the discrete data numbers work. And then you have divide by 4. Okay, so divide by 4 because the quarter of it. So which is 4. Fourth number, 1, 2, 3, 4. There we go. And to find upper quartile, you do 15 plus 1 divided by 4 times 3. It's 3 quarters, which is 12. So if that's the 8th, 9th, 10th, 11th, 12th, so that's the upper quartile. And here we go. These are all the numbers. Here's the next example. So we're done with plotting a box plot. I don't think it's very difficult. So what you need to do, what we're going to do next is to interpret it to compare results, which is what you normally do in the exam. So a group of students did a maths test. You got the girls' result and the boys' results. We are asked to comment on the performance of the girls compared to the boys. Now in a box plot, when you do comparison, two main things you want to compare. The first one is the median, okay, because median is a type of average. So you can sort of use the median to say on average, how did everyone do? So you want to use the word on average, okay. The next one you want to use is the IQR, the interquartile range, because the interquartile range tell you about the consistency of the student's ability. So these are two things. When I ask you comment on anything about box plot, compare box plot, you're going to compare about median and IQR. Now, equally, you might be asked to compare a box plot with a cumulative frequency graph. Same thing. You want to compare about the median and the IQR. Okay, so hold this. These two things is the main thing you want to do when it comes to commenting on comparing different types of representations. So, but rarely, sometimes you might want to compare, you might want to comment on the minimum or the maximum. Like in this case, you can see the minimum is far below than the other, then you might want to say something about the minimum. All right, so let's have a dive into this question. Now, first of all, we need the median. Okay, so what can we say about the median? Well, we can see the girls' median and the boys' median are the same, 75. So that's the first thing you would say, okay? So you would say the girls and the boys have the same median of 75. Okay, so what does that mean? So after you present a number, you have to explain what it means. It means, okay, on average, okay, both boys and girls did similarly well in the test. So the keyword is the word on average. Okay, so on average. So next, so you've done that. Okay, so you have compared the median. Next thing, the IQR, interquartile range. So what about interquartile range? Well, the girls, the interquartile range is a difference between the lower quartile and upper quartile. So if I read off the increments, that's 63, that's 80. So the difference here is 17. Whereas the boys, this is 66, and that's 85. So the difference in here is 19, right? 17, 19. Yep. So what can we say then? Then we can say the boys have a slightly larger IQR. It means they are less consistent than the girls. So as I said, you want to say the girls' IQR is 17 and the boys is 19. So showing that the girls had a more consistent performance than boys, because the IQR means how spread out the boys' data is. The larger the IQR means the bigger gap between the lower quarter, upper quartile. So that means the boys are generally doing a bit more, have a wider range of scores than the girls. Okay. Now, I did mention about the minimum. In here, you can see the minimum of the boys has a particularly low than girls. Now, what does that mean? That means you do want to comment on this if you're given, let's say, if the question is probably 5 or 6 marks. Say, let's say they need 3 things for you to compare, then you can do say about for the maximum. There's not much of a difference, so you don't really have to compare any of them. You can if you want to, but the minimum. So it means the minimum the boys is 35 compared to the girls of 50. So now, the minimum does not represent anything, it just represents one student. So it could mean just one student in particular did really unwell, did really bad. So we can say that's an outlier. So, however, the boys had a much lower minimum score of 35. Now, again, the number is key in here. You do have to mention about the numbers, okay? Compared to 50 in girls, so which means one particular male student didn't do so well. All right, so that's the how you mean to comment on them. 2 things again. Remember, the median and the IQR are the 2 things. Here comes practice question 3. The box plot below show the average waiting times in the 2 NHS. Hospitals. Nothing will do at NHS. It's just hospital A, hospital B. If there are any coincidence about the waiting times that being quite long, it's just a coincidence, pure coincidence.
Yeah, boy.
Trust me. Comment on the difference of the death rate. The waiting times. Sorry about, English is my problem. No one heard any stories about people dying because of the unbearably long waiting times in the hospital, right? Due to their inefficiency.
Oh, okay.
Now, again, not NHS, it's just normal hospital in somewhere in UK that we don't know, right? So have a go at a question. When you're ready for the answer, you can press play. So here's the answer. Okay, so hospital A has a median of 80 minutes and hospital B of 58 minutes. Now be careful with the increments of the horizontal axis. Every small square means 2 minutes. Okay, so be careful with it. So 58 minutes, because if you got this wrong, they will take you marks away from it. Which means on average, the waiting time of hospital A is longer than B. Right? Also, you have to mention about interquartile range. A clearly has a wider, bigger interquartile range than B. To show it, you have to work out the numbers. You do 40, and then this one is 94. So 94 take away 40 is 54, and B is 26 minutes, which means hospital B's waiting time is consistently. So I mentioned the word consistently for interquartile range, and on average for the median. Okay, so you learn to use these 2 words, lower than A. So that's what you have to say about the difference, about the comment, right? Here is practice question 4. Below table shows information about London's temperature. They are record low and record high. Record high, I think, was 2022 summer. Was the heat wave. It's crazy. I was there and there. Anyway, so draw a box plot in the space below, and then also have a go at question B and see about commenting the difference. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Okay, so question A, box plot, should be fairly easy. Putting these numbers in and draw a box plot. For question B, now slightly trickier in this one, and give a possible name of country X, so you have to use a bit of your common sense to understand where country X is roughly be. So if you use anything about Dubai, Qatar, about anything about Middle East countries or the Asia countries, then you should be okay. One would be thinking, why would Dubai be have a median of that low of 28 degree? On they like 30 something degree? Again, actually, when I think about country X, when I make the question, Dubai was the country I was thinking about. Where I actually used Google to help me work it out. I think probably maybe because of the desert and in the evening they could be quite chilly in there. So I think that's why the median is being dragged down possibly. But anyway, anything about Middle East countries or Asia countries will be fine. Okay, so part C. Erin loves bringing a light suitcase when traveling. Now, which place would you recommend her to travel? London or country X? Provide 2 reasons to support your answer. First one, you will have to say country X because, well, clearly, median. Talk about median. Country X is a higher median, so it means you do not have to pack any thicker jackets or anything, something like that. So lighter suitcase. But also now this time the interquarter range does not quite work because you can say interquarter range, but the consistency of temperature doesn't provide you anything about lighter suitcase. Just because one country has a more consistent temperature doesn't mean they have. For example, if you have a when you compare to, let's say, North Pole compared to, let's say, pick a hotter country like in Africa, yes, North Pole probably have a more consistent range of temperature, which is maybe interquartile range might be, let's say, because let's say a few degrees, because they're always so cold, it'll be negative degrees in there. But in Africa, where you have a larger interquartile range, because in the evening it will be colder than the afternoon, but it doesn't mean that. But however, if you go to North Pole, you will have to pack a lot more clothes than Africa, wouldn't it? Because even though the interquartile range is smaller, a bit more consistent. Now, consistent doesn't mean it could be consistently good or consistently bad. In North Pole, it would be consistently cold. Okay, so it doesn't help you with the lighter suitcase. So you have to pick and choose your fights. In here, what you want to use is you can use your range. Range is the maximum, take away the minimum. So the range of London is 44 degrees because from 38 to 16, now of course that's quite extreme, 44, whereas country X is just 24. It means if you have such a wide range of temperature in London, then obviously when you have to pack for traveling, you will have to pack for more scenarios, right? So if it's really cold, you pack a lot more. If it's really hot, you pack for your summer things. For your, let's say, if you want to go to the sea, the beaches, then you have to pack your summer suit, right? Swimming suit, so summer suit, swimming suit. Summer suit is that thing, swimming suit. But whereas in, let's say, in Dubai, you just have to pack your swimming suit, nothing to do with the jumpers, anything about the ice skiing stuff. So that's it. That's the answer.